Hi guys, it's another weekly video. So we finished the lithosphere module, oh my goodness, and we're starting the hydrosphere module. So I did send you out earlier today an email with the copy of the syllabus. We haven't got a resource booklet unfortunately because I only have a paper copy and it's back at college, which is currently closed. Looks like potentially there might be a college opening of some sort in June, still very uncertain. If there is, I might have an opportunity to photocopy and give you a hard copy, but it's probably safer to assume we won't have the resource booklet than otherwise. Anyway, so the hydrogen module, which is a really interesting module, it's the last module from year one, and it's quite a small module as well, so it's probably about half the size of the living environment, a little bit smaller than the lithosphere, so we should be able to do it in about 4 weeks, something like that. And also remember we started a little bit of it on the field trip when we were at Meldon Dam, North Dartmoor, so we talked a bit about dams and reservoirs and some other impacts. So I'd like to do a few things before we have our live lesson this Thursday morning. So the first thing I'd like to do, if you have a look in your textbook, page 93 to 94, there's a little bit of stuff about the properties of water, and that is actually a recap of the beginning of the living environment module when we talked about conditions for life on Earth. Water being a solvent, for example, the fact that it's unusual and it expands when it's a solid, this anomalous expansion, those kind of things. So have a quick read through, just remind yourself about some of the unusual properties of water. That shouldn't take you more than literally sort of 10 minutes. The main thing I'd like you to do, well, main two things I'd like you to do. The first one is I'd like you to do some research actually and do some reading. So I want you to, if you like, set the scene for the hydrosphere module. You know, what is happening to global water resources? Why do we have a problem? So it really splits into two categories. So the first one is the problems of not everyone having access to clean drinking water. And the second problem is not everyone potentially having access to water for farming, for drinking, etc. So you can kind of split your research into those two categories. One is sort of shortages of water, and one is sort of people having water but perhaps not having clean water. Now on the Moodle site there's lots of resources I've managed to find on this. They're all in the first sort of half a dozen or so links on the Moodle site. I'm just having a look down now. It's the section you can see a picture of a dam. So there's the first one is global water crisis. And then there's one, is the world running out of fresh water? There's one about climate change and water shortages, global water shortages. I can see a little bit further down. So have a look at some of those Moodle. They're mainly links to BBC articles, but have a look at some of those Moodle links. For the lack of access to clean water, I've put a link to the WaterAid website, which is a charity which tries to install sort of clean drinking water in developing countries, so you can have a look at that as well. Don't just restrict yourself to what's on the Moodle site. There's loads of information on this. You could put global water shortages into YouTube, you'll find lots of videos. You really won't struggle to find lots and lots of articles. So I'm after sort of facts and figures. Examples of shortages, which countries are they happening in, why are they happening, just to sort of set the scene really. Bear in mind in this subject you will have essays at the end of the second year, and it is quite conceivable that your essay could be something like discuss the reasons for global water shortages and how we can solve these problems. So you'd need quite a lot of information. Remember, you have about an hour for your essays and you're probably going to be writing maybe 4 or 5 sides, so you need lots and lots of sort of facts and figures that you could put in an essay. So I'd like you to do some research and I'd like you to write that up in some kind of format that suits you. I don't really mind too much how you do that. It needs to be in your own words though, so not just printing stuff off, but you need to sort of handwrite it. Could do a spider diagram, could just do notes, leave it up to you on that. Anyway, so that's the first thing I'd like to do, and to try to do that ready for Thursday's live lesson. The second thing I'd like you to do is to draw out a diagram of the water cycle or hydrological cycle. Now it's done in your textbook on page 95. It's okay, the diagram is not brilliant, so I think it would be quite good if I kind of draw one out. It's a bit similar to I've drawn some of the biogeochemical cycles out, so I'm going to sketch it out quickly on my whiteboard, and then using the video and using the diagram in the textbook, I'd like you to try and draw out a neat version with all the sort of stores and all the processes and transfers that are happening in the water cycle. And in the live lesson on Thursday, we'll have a look at some of the exam questions that you might be asked about that. So I'm going to move the camera around now to the whiteboard, and I'll go through the hydrological cycle. So just bear with me as I just try to get this zoomed in, same as last time. Alright, so let's just zoom in a little bit. Well, not brilliant. Let's see if we can move that over a little bit further. So I've got a little bit more space. So let's just move this across. So this diagram is going to be in cross section. So again, if you've got A3, that would be brilliant. If you've got A4, then that's fine. So got a nice cross section here showing you the water cycle. So we'll start on the oceans now. I'm going to struggle on here to fill in or write out a lot of the stores and transfers, because with these thick board pens, and this is a very small whiteboard, I'm going to run out of space. But obviously you can write much smaller in pen. So I'm just going to kind of take you through it. So any of the stores on your diagram you want to be putting as a box. So we can start off in the oceans over here, and this is obviously this season ocean store. And then some of the sort of transfers and processes. Well, we have the process, obviously, evaporation, and that's when water is going from liquid to gas, the hydrogen bonds breaking. And then there's that water vapour rises, water in the form of a gas. Of course, it reaches what's called its dew point, D-E-W, its dew point, and it condenses into clouds, which are effectively lots and lots, trillions of little water droplets. So we've now got a store in the atmosphere as water vapour and in clouds. So we can put on evaporation as a process here, and obviously condensation as a process here, as that water vapour condenses out into clouds. So we've got stores in the atmosphere as a gas, we've got stores in clouds. We'll have those clouds moving inland, as often happens, and as winds blow over mountains, the air is forced to rise further, and as it rises it cools further, more condensation, and you typically get lots of rainfall over hills. Geographers will know all about that process. So we can then label sort of precipitation over here. Okay, again, I'm not going to write it on because I run out of space. So precipitation, which is a general name for snow, rain, sleet, all of those things. And then what happens to that rainfall as it reaches the ground? Well, it's got a few different options, hasn't it? So one option is it could run over the surface, what's called surface runoff or overland flow. Again, you can be labelling on these processes. The other option is it may infiltrate into the soil, and infiltration is just a fancy name for water going from the surface into soils. Again, you can label it on infiltration, and you can then label another store. So remember, so far we've got a season ocean store, we've got an atmospheric store. Again, we can put these in boxes. We've got a store in clouds, and then we've got a soil moisture store down here. So this you could label soil moisture store, and then as the water works its way further down, it's no longer called infiltration, it's now called percolation. So percolation is just a name for the downward movement of water through soils and through rocks. So infiltration going from the surface into soils, anything below that point is called percolation. Again, you'll see a lot of these things on the diagram that's in the textbook. So as you go further down, of course down here somewhere we could have a groundwater store here. Okay, so groundwater store, soil moisture store, and probably somewhere between the two you could put some kind of dotted line, which is what's known as the water table. Okay, so the water table is the top of the saturated zone underground. So in winter, for example, in the UK, the water table may actually be quite close to the surface. In summer, the water table may drop a little bit lower. So the water table is the name, as I say, for the top of the saturated zone of water underground. And globally, of course, water tables are dropping all the time as we take more and more water out of aquifers and groundwater stores. Anyway, back to the diagram. So we've got soil moisture store, we've got groundwater store. Now there are also movements sideways. So for example, water will also move sideways through soils, and that's known as through flow. So water moving sort of sideways through soils in this direction, so through flow, and then a little bit further down, right at the bottom in fact, we've got what's called groundwater flow or base flow. Okay, so through flow is something that's generally happening in sort of soils, the sort of sideways movement of water through soils. Groundwater flow or base flow is the movement of water through rocks. Okay, and this is quite important because when you think about when it rains, how quickly the water gets to a river. So if you imagine rain falling here, the first transfer, the surface runoff, gets to streams and rivers very quickly, sometimes just within a few hours. However, when it stops raining, rivers don't dry up. You know, the River Tone in the centre of Taunton doesn't dry up if it doesn't rain for a couple of days. Now, the reason rivers don't dry up when it stops raining is because they're also topped up with some of these movements through flow, for example, through soils, and that takes a little bit longer, might take a few days for that, or even a week or two for that to reach rivers. And groundwater flow or base flow, well, that might take many, many months to reach rivers. So rivers are fed by both surface runoff through flow, which was the sideways movement of water through soils, and groundwater flow or base flow, which is the sideways movement through rocks. Alright, so we've got most of the stores here. What else could we label on the stores? Well, we've got a store here in biomass, so stores in sort of vegetation and living things, you could label that on. Here we've got a lake, so we could label this as a surface water store. So biomass store, surface water store. And then we've got a few other sort of processes sort of going on. We could have uptake of water by plants, and you probably know the name for plants evaporating out that water vapour through their stomata. So that process is called transpiration. Sometimes in the exam you'll see it called evapotranspiration. So evapotranspiration is all of the sort of water vapour coming off plants, both evaporating off the leaves but also coming out through the stomata. So you can label on evapotranspiration, and I think that's most of the processes in the hydrological cycle. I'm just going to have a quick look at the textbook and just see if there's anything that I've missed or that we need to label on. Looks pretty good, I think. The only other thing you could maybe think about is the size of some of these stores and the length of time that water stays in these stores. So some of the largest stores, it's not really a surprise to think that globally most of the water would be stored in the oceans. A much higher percentage, about 97% in fact of all the water on the planet is stored in seas and oceans. The problem of course is it's salty, so it's not necessarily available for us to use. Salty water is phytotoxic, which means it's toxic to plants. You can get the salt out, but that's very expensive, very energy intensive to do that. In terms of sort of other very large stores, then land ice is the second biggest store. So if you think about sort of fresh water stored in ice sheets in Greenland and Antarctica, that accounts for about 2% of all global water stores. So we've got 97% of the seas and oceans, 2% stored as land ice, which obviously only leaves very small amounts found in these other stores. The other thing in the exam, as I say, they ask you about is the residence time, is how long the water stays in these different stores. And some of these stores are very, very short. For example, if you think about the atmosphere, water typically only stays in the atmosphere for a very short period of time, because very quickly water vapour condenses into clouds and then precipitation, and it leaves the atmosphere. Whereas, for example, water that's stored maybe in groundwater, that has a very, very long residence time, often many sort of thousands of years. There's another way of thinking about residence time, which is if you emptied a store completely, how long would it take to refill? So if you removed all of the water from the atmosphere, how long would it take for it to be replaced? By things like evaporation, well, that would happen quite quickly. Within about 10 days, all of that water would be replaced back in the atmosphere. Whereas if you removed all of the water from all the seas and oceans, it would take probably hundreds or thousands of years for those seas and oceans to refill. So you can think about residence time in that way as well. Anyway, that's the water cycle diagram. So have a look at this one, obviously have a listen to the video, have a look at the one in the textbook at the top of page 95, and if you could try to draw out your own version once you've had a look at both, and get that ready for Thursday's lesson, and then we can have a look at some exam questions and how you might be asked about it. Okay, thanks guys, and I will speak to you on Thursday.